Now, this is putamen, right? But actually, in this diagram, I'm showing only putamen, but when I talk about putamen, it should be considered in association with caudate nucleus. And you know, caudate nucleus with the putamen are called neostriatum. What are they called? Neostriatum, right? And this is of course globus pallidus, right? Now let's start with how the system starts. First of all, when you're going to do movement, cortex should, yes, connect with the basal ganglia. So cortical fibers, yes, they come down and they stimulate neurons in neostriatum. They stimulate the neurons in striatum. This is striatum. Again I'm repeating. Caudate plus, what is this? Putamen. For motor purpose, most of the fibers go to the putamen anyway. So I will call it now onward striatum, but not corpus striatum, because when we say corpus striatum, it includes globus pallidus also. I will just say striatum. So these are corticostriatal fiber. What are these? Corticostriatal fibers, right? Then from here, very important connections are going to the, what is this? Globus pallidus internus, right? And from there, fibers are going, what is this? Thalamus. And then it should loop back. And then it should loop back. So what is this? Look here. Fibers start, and this is a very simple loop. Things are going directly back. This is also called direct pathway, right? Now what is direct pathway? We'll talk it later in detail. First of all, what is this? Corticostriatal fiber. Then what are these fibers? Striato-pallidal fiber to the internal globus pallidus internum. Then pallidothalamic fiber. Then thalamocortical fibers. Do you think it's difficult to understand? It's very simple. Now, first of all, I will tell you, when you are resting and not doing any movement, what is going on? First we should understand, when you are resting and not doing any movement, what is going on in this circuit. And then we'll discuss when movement start, a plan of a movement, you start, right? Then what firing occur, first of all. These red neurons are releasing stimulatory neurotransmitter. Red neurons are releasing stimulatory neurotransmitter. The neurotransmitter released by this is glutamate. What is released from here? Glutamate. And this is also releasing, yes, glutamate. So fibers coming from the cortex to basal ganglia are glutaminergic, and from thalamus going back are also glutaminergic. Now when glutamate is released from this nerve ending to this dendrite or cell body, glutamate receptor will produce cation influx. When there will be cationic influx, this will get stimulated. So glutaminergic fibers will stimulate this first neuron, striatal neuron. Then striatal neuron releases normally what? GABA, gamma aminobutyric acid plus substance P. This neuron, when this neuron is stimulated, its nerve endings release gamma aminobutyric acid along with the substance P on the neurons of globus pallidus internus, right? So this neuron should be considered GABAergic neuron. And the next neuron in the line, which is concerned with the pallidothalamic pathway, that is also GABAergic neuron. What is that? That is also GABAergic neuron. And again glutaminergic. Now, first of all, I will tell you what happens when you are not doing the movement. When you are not doing the movement, these corticospinal fibers which are going to come down, you know this fiber which was coming down. Let's suppose I show that fiber here. Here I show corticospinal fiber. Of course they are going down, and lower motor neuron going out. Is that right? To a muscle. Now, when you are not doing any movement, it means these neurons are not firing. Is that right? It means motor cortex is over functioning or under functioning when you are not doing the movement. Look, throughout the lecture we will use the logic. When you are not doing the movement, motor cortex here should be under functioning or over functioning? Under functioning. It should be inhibited. Is that right? Actually, how it is kept inhibited when you are not doing the movement? Actually, when you are not doing the movement, when you are at rest, globus pallidus internus is actively firing when you are not doing the movement. Globus pallidus internus is actively firing. When globus pallidus internus is actively firing, it is releasing GABA on thalamus. On which nuclei of thalamus? Basically, the nuclei of thalamus is ventro-anterior nucleus, ventrolateral nucleus, centromedian nucleus, dorsomedial nucleus. But anyway, listen. What I'm going to tell you that normally when you are at rest, you are not doing any movement, pallidothalamic fibers are very active. Right? These pallidothalamic fibers are GABAergic fiber, GABA releasing fibers, and these fibers are releasing a lot of GABA in ventro-anterior nucleus of thalamus, ventrolateral nucleus of thalamus, and dorsomedial nucleus of thalamus. Is that right? Now, when GABA is released on these neurons, gamma aminobutyric acid is stimulatory neurotransmitter or inhibitory? It is inhibitory, because when GABA is released on a neuron, GABA receptor either allow the chloride influx and make the neurons very hyperpolarized, or GABA receptor allow the potassium efflux, and again loss of potassium makes the neurons very hyperpolarized. So what happens? Gamma aminobutyric acid is normally released by pallidothalamic fibers, right, tonically in very high amount when you are resting, and they keep the thalamocortical fibers inhibited. You are understanding? When these neurons will be inhibited, so naturally can they stimulate this? No. So movement will not be there. You understand it? This is what is happening at rest. Can you repeat it? What happens at rest? Say rapidly. There is a heavy firing by pallidothalamic pathway, which are GABAergic fibers, releasing lot of GABA in ventroanterior, ventrolateral and dorsomedian nuclei of thalamus. GABA inhibit these neurons. Then what happens? Thalamocortical fibers are inhibited, no action potentials. So these fibers do not stimulate the upper motor neurons, pyramidal neurons going down to the lower motor neuron. That's right. Now, you are resting, suddenly a nasty idea came to your mind and you decide to make a certain movement. You're going to do certain movement. I will not tell what movement, but certain movement. Now, if you're going to that certain movement, what will happen? First of all, you need to consult basal ganglia. Secondly, this is automatic brake applied on the basal ganglia. Basal ganglia is keeping an automatic brake on the motor system that should be released. So exactly what happened. When you think of a movement, right, let's suppose these neurons plan a movement and they stimulate this. Now corticostriatal fiber will come. Now corticostriatal fibers are releasing what thing here? Yes, please. Glutamate. Glutamate will stimulate the striatopallidal fibers. Now, when these fibers are stimulated, listen, glutamate receptors are present here, right? And glutamate will bind here, cations will be loaded, and this neuron will become active. Action potentials will move through and then release here GABA. So this first blue neuron, striatopallidal fibers, release GABA on pallidal neurons. When they will release GABA on the pallidal neuron, these pallidal neurons, globus pallidus internus neurons, will be stimulated or inhibited here? Inhibited, right? So let's put it like this. First of all, these neurons are stimulated. When you are planning to movement, they are stimulated. Their activity is going up. And when their activity is going up, what they release here? Glutamate. When they release the glutamate here, what happens to activity of this neuron? It goes up. So these are also, yes, stimulated. And when these neurons are stimulated, striatopallidus internal neuron, they release what substance here? GABA. And when they release GABA, what happened to this neuron? Pallidothalamic pathway. There are two important pathways here. One is ansa lenticularis, other is lenticular fasciculus. But anyway, important thing is concept here. When first inhibitory neuron inhibit the second blue neuron, right? Now this will be inhibited. So action potential in this neuron will be more or less? Less. So what happened? Activity become less here. When activity become less here, then thalamocortical fibers are released from the pallidal inhibition. Because when you were resting, these fibers were too much firing and keep the thalamic neurons inhibited. But now when you decided to make a movement, corticostriatal fiber, which are glutaminergic, stimulated the striaglobus internus fibers. When these fibers got stimulated, they released inhibitory neurotransmitter on pallidal neurons, and pallidothalamic fibers get inhibited. And when they get inhibited, then there is less GABA release. Attention please. When these fibers get inhibited, less GABA released in thalamus. So thalamic neurons are less inhibited, or you can say they are disinhibited, or they escape the inhibition. Is that right? So when they escape the inhibition, they start firing, and message goes, yes, message goes to upper motor neurons, and they are stimulated, and fibers go down, lower motor neurons are stimulated, and muscle contract. Any question up to this? What is the role of thalamus here? Thalamus is acting as a relay station, right? That relay station, number one. Number two, very important thing. Thalamus has very intimate relationship, even though it is at distance, with the cerebellum. There are a lot of, you can say, fibers coming from cerebellum to eventually, through multiple relay, to the thalamus. So thalamus knows the information in the cerebellum. And information in cerebellum is what is the proprioceptive position in the body. Cerebellum knows which muscle is in, which muscle or which joint or which tendon or which ligament is under what type of proprioceptive situation. What is the degree of bend at joints, or what is the degree of tension at muscles or ligaments or tendons. This information from cerebellum is being relayed to thalamus. There, basal ganglia information and thalamic information, they will be computed together, and then final decision will go up. But that we will talk later, right? Let's come back. Any question up to this? So it's so easy to understand. When you are resting, these blue neurons are overfiring, lot of GABA in thalamic nuclei. Thalamic nuclei inhibited, thalamocortical fibers inhibited, no stimulation to the downgoing corticospinal corticonuclear fibers. But when movement, you are planning for a movement, first of all, corticostriatal fibers, which are glutaminergic fiber, stimulate the striatal neuron. And striatal neurons, when they get stimulated, this pathway releases GABA in globus pallidus internus, neurons in globus pallidus internus get inhibited, then pallidothalamic pathway, oh my god, yes, this get inhibited. So pallidothalamic pathway does not release GABA in thalamic system, and when inhibitory neuron is deficient here, then thalamic neurons are released from the inhibition and they fire upward, right, to the cortex. Of course, what is this? This is going to premotor cortex, supplementary motor cortex, primary motor area, and somatosensory area. And there, the neurons which are going down, they are activated. Any question here? This is called direct pathway, right? Now we'll come to that fussy thing about indirect pathway. What is indirect pathway? Let me tell you. There is one more pathway when we start for the movement, and let me tell you why we need two pathways. Listen. Let's suppose my hand is like this. Okay, my hand is like this, and I want to close it. Right? So motor planning should be of two types. Number one, flexors should contract. Number two, extensors should relax. Are you understanding? Even when you are going to do any movement, your posture should be adjusted, right? And tone in other muscles where active movement is not done also need to be adjusted. Is that right? For example, right now, if you are writing something, try to write. Not only your hand muscles will change their movement, but you will find shoulder also has change in the tone. Try it. Try to write something. It means actually Basically, this is a function of the basal ganglia. We originally in our mind we planned to write something with the hand, but why all this tone and postural platform is altered? This is also all planning by the basal ganglia. Is that right? Now, one thing which is important, as I told you, that if I have to close my hand, flexors should contract, but at the same time extensor should relax. It means basal ganglia should have two pathways. One pathway should be stimulatory to some muscle group, another pathway should be inhibitory to other group. It means agonist should be stimulated and antagonist should be inhibited. It means there should be one more pathway, because this pathway is only stimulatory. Now we'll talk about the second pathway. Look here. This is when we are planning for the movement. Another pathway here, it is initially it is the same. What is it? Corticostriatal fibers. From these are glutaminergic fibers, and from here fibers go to globus pallidus externus, not internus. You see, this is going all the way globus pallidus internus, the direct pathway. But when we talk about indirect pathway, the fibers from striatum go only to the globus pallidus externus. From there, the next neuron, they go to, what is this? Subthalamus, right? And then from subthalamus, glutaminergic neuron go to, what is this? Pallidum. And from the pallidum, globus pallidus internus now, neurons are going to thalamus. Now, this pathway involves an extra loop. Here the fibers are going from striatum, listen, from striatum directly to globus pallidus internum. So this pathway was direct pathway. Here the fibers are going from striatum to externum, globus pallidus externum, via the subthalamus, go to the globus pallidus internum, right? So, look, striatum is influencing the output of globus pallidus internum directly or indirectly via subthalamus. So that is why this pathway is called direct pathway, and this is called indirect circuit or indirect loop or indirect pathway. Am I clear? So what is indirect pathway? Where striatum is influencing the activity of globus pallidus internum indirectly via a loop through subthalamus. Is that right? Now how this pathway work? Again, the corticostriatal fibers are glutaminergic and they will stimulate. So again, these fibers are what? When you are planning the movement, these are stimulated. Action potentials are more in these glutaminergic fibers, but these glutaminergic fibers are different than the previous fibers, because these fibers end up on such striatal neurons which go only up to globus pallidus externum, right? So they will stimulate first these blue neurons, and when these blue neurons will be stimulated, their activity will increase. Is that right? But what they will release on the next neuron? Yes? What they will release? These neurons will release GABA. When GABA will be released, what will happen to the activity of this neuron? It will be inhibited. So we can say activity in this neuron is less. When activity is less in this neuron, right, which is globus pallidus externus to subthalamus, when it is less active, it is releasing less GABA on these neurons, right? When it is releasing less GABA, it means this is less inhibitory. Is that right? So it means this will be released from inhibition. And when these fibers, which are subthalamo-pallidal fiber, when these fibers are having less GABA influence, they are having less inhibition, or we say they are disinhibited, so or they are released from the inhibition, so they overfire. And when these fibers will overfire, they will release a lot of, what is this, glutamate in which area? Globus pallidus internum. And when there is glutamate released, that will stimulate this pathway. And when this is stimulated, oh my God, yes, that's right. These fibers will be stimulated. So they will produce more GABA, where? In thalamic nuclei. And when there will be more GABA, what will happen to this neuron? This will be stimulated or inhibited? That will be inhibited. And this will be connected with some those system which need to be inhibited. Maybe in this example, this pathway is bringing information eventually to the extensors. So extensors will be inhibited. You are understanding? No problem in this? Why you are looking so happy? You are understanding it? Okay, that's good. I'm happy for you. Now, again, start the direct pathway and then we'll discuss the indirect pathway, then we'll make their comparisons, right? Direct pathway is, now you people will tell me, cortico-striatal fibers, right? But real difference is from here, that from striatum, GABAergic fiber are directly connected to globus pallidus internus, and from there, fibers are connected to the thalamic nuclei. What is happening? When direct pathway is activated, cortico-striatal fibers release glutamate, stimulate the striopallidal fiber, stimulated striopallidal fiber, which are GABAergic fibers with release of the substance P, they release GABA on internal pallidus, globus pallidus internus neurons. Those neurons are inhibited, and when they are inhibited, they don't release GABA in the thalamus. So thalamic neurons are not inhibited, so they will be overfiring. And when thalamic fibers, which are thalamocortical fibers, they're overfiring, when they will go up, they will stimulate the upper motor neurons. Is that right? For one group of muscles, maybe suppose here flexors. Clear? At the same time, we need to inhibit some other neurons. So we can say, first of all, indirect pathway. Indirect pathway, when it is overfiring, cortico-striatal, what will happen? It will stimulate GABAergic neurons which are going from striatum to externum pallidum. They will inhibit the fibers which are going from, pallido-subthalamic, and there is less release of GABA release in the subthalamus. So subthalamic neurons are not inhibited anymore. They overfire and release glutamate in globus pallidus internum, and glutamate stimulates the inhibitory fibers, GABAergic fiber going to the thalamus, and they release a lot of GABA and inhibit these thalamic neurons, and these thalamocortical connections are inhibitory. So what did we see? Direct pathway, when it is stimulated, it is stimulatory. Indirect pathway is basically inhibitory. Is that right? Now let's compare and contrast direct and indirect. First of all, direct pathway is shorter pathway and does not involve subthalamus. Indirect pathway is longer pathway and involves the subthalamic connection. Direct pathway, when stimulated, eventually it stimulates the thalamocortical fibers. So it is for movement activation. Indirect pathway, when it is activated, it actually inhibits the thalamocortical. Some of the, of course, these will be different fiber, those will be different. It inhibits the thalamocortical fibers to inhibit certain upper motor neurons. Is that right? Any question here? There is no problem. Now, this is the basic connections. Now we come to role of dopamine, substantia nigra. Who is clear about this role? Yes, you want to say something? Substantia nigra, what is the role of this? Actually, these are the primary circuit. It is like a fine tuner. It's like modulator, right? The real action is here, direct and indirect pathway. This will be now doing some modulation. Yes. What? Help in the movement. How? Look, you must be knowing that there is substantia nigra which is present in midbrain, derivative of mesencephalon. In whole this pathway, which are the structure which are derivative of telencephalon? Telencephalic structures are caudate, putamen, globus pallidus. Is that right? Telencephalon. Diencephalic structure is, what is this? Subthalamus and thalamus. And mesencephalic structure is substantia nigra, right? It is in the midbrain. Now let's see how the substantia nigra work. This is pars. This is pars compacta. This is pars reticularis, right? Now, actually what happened? Yes. From here, GABAergic, okay, I will not go into this connection, but more important, which is very, very important connection, that from here, what is this? Pars compacta, right? Here are the neurons which are dopaminergic. They release the dopamine. What do they release? They release dopamine, and these dopaminergic neurons go up and release dopamine on both pathways. Now these are dopaminergic nerve endings. It means that substantia nigra, dopaminergic fibers, which can also be called nigrostriatal fiber, influence the direct pathway as well as indirect pathway. Is that right? They influence the direct pathway as well as indirect pathway. Actually, these dopaminergic fibers help in initiation of the movement. They facilitate the movement. Now, as I assume all of you are intelligent, so you can tell me if this pathway is supposed to enhance or initiate the movement, kick-start the movement, right? This is the, you can say, kick-starter of the motor system, right? As in the motorcycle, there's a kick-starter. So movement initiator. Now this neuron, which is dopaminergic pathway, if it has to facilitate or initiate the movement, you should be able to infer yourself that what should it do to direct pathway and indirect pathway. If it should start the movement, you know, direct pathway is excitatory pathway and indirect pathway is inhibitory pathway. If it has to facilitate the movement, right? So direct pathway should be stimulated or inhibited? Stimulated. And indirect pathway should be inhibited. So what really happens? That nature has provided here D1 receptors. When dopamine is released on D1 receptors, right, these neurons are stimulated, and when dopamine is released, same dopamine is released on indirect pathway D2 receptors. D2 receptor produce inhibition of the neuron. Paul, am I clear? What I'm talking about, that this dopaminergic pathway influences the, releases dopamine in striatum. We call it nigrostriatal pathway, right? In some books it's written it stimulates some fibers and inhibits other fibers, but some good books are now telling that dopamine release on direct pathway stimulates the direct pathway, and dopamine release on indirect pathway inhibits the indirect pathway. The question was that how one neurotransmitter and one side is stimulating, other side is inhibiting. Now we know the answer. Actually here, in these two places, the receptor for dopamine are different. When D1 receptors are attaching, when dopamine bind with D1 receptor, neurons are stimulated. It means their cationic loading, cation will go in. But when dopamine will bind with D2 receptors, intracellular signaling will eventually lead to cation release from the neuron. So neuron will be inhibited. Is that right? Now, rest of the story should be very simple. What should happen? When dopaminergic system is facilitating the movement, and dopaminergic system is facilitating the movement, what should it do? It should stimulate direct pathway. It means direct pathway is stimulated. Is that right? What will happen? More GABA coming here, and internal is neurons in globus pallidus internum are inhibited, and they are further released and more firing for direct movement, right? At the same time, this is producing a very fine balance, that at the same time they are inhibiting the indirect pathway, because D2, when this neuron is inhibited, then less, now here it is reversed, not what is shown, actually it will become less active. What is this? Under the influence of dopamine, right? And less active So it will release less GABA here. So this pathway will be less inhibited. So produce more GABA. More GABA will inhibit it a lot, and this activity will go down. So it will not be stimulated. It will be less active. Are you understanding? And when it is less active, less GABA over here, this will be also released. So basically, dopaminergic firing on both sides increase the action. You are looking a bit confused. Indirect pathway. Yeah, let me tell you. When we talk about corticostriatal system, right? This stimulates this pathway, increases the movement. And when corticostriatal pathway come to indirect, it decreases the movement, right? Right? But when we talk about dopamine, right, nigrostriatal pathway, is that right? What it has to do, it has to facilitate the movement more. For this purpose, especially it stimulates the direct pathway. I told you direct pathways, excitatory pathway or movement initiatory pathway. This is because concerned with the antagonist, right? This is inhibitory pathway. So listen, again, final movement occur depend on what thing? Motor cortex activity. Depends on what thing? Motor cortex activity. Now motor cortex activity is normally increased by direct pathway, normally decreased by indirect pathway. Is that right? But if nigrostriatal facilitate the desired movement is supposed to close my hand. So for this purpose, it should enhance the activity in direct pathway and inhibit the activity in indirect pathway. Am I clear? Are you clear or not?
Well, how does the cortex talk to the
How the cortex talk to this thing? Yes, I was thinking that one of you should be really intelligent. That how the substantia nigra neurons know when to fire and which group of neurons to fire and readjust. Of course, they have very close relationship. What are these fibers? Corticonigral fiber. So this information, substantia nigra knows what is the planning going on, and it will further fine tune it. Is that right? Any question up to this?
So basically that inhibitory pathway that dopamine activates still does inhibitory, right?
Yeah, but it is less inhibitory.
Less than the one that
Let me tell you, exactly tell you what it happens. Basically, when you plan a movement, body has a tendency to overshoot in the movement. So we have to find regulators. You will get this concept more clear when I talk about Parkinsonism. When this pathway is destroyed, what happens?
I'm getting confused. So if you
Okay, let me tell you. Forget about this pathway. I'll start another pathway here. It should go through this. Actually, I have put it on the same neuron, that is why it is disturbing. Now what is happening? This dopamine.
Can I explain?
Yeah, you can explain, why not? Come over here and explain.
No, I don't want to.
No problem, it's okay. You are still in learning phase. If you make a mistake, still you should be appreciated for coming over to the board.
Okay, so we are releasing dopamine here.
Yeah.
To D2 receptors right here.
Yes.
Okay? So we are which are inhibitory, so we'll get the.
Look, I will tell them what you are saying. You are saying when dopamine will come over here, it has D2 receptors.
Yeah,
So this get inhibited.
Right.
When it get inhibited, right,
Less GABA.
you will stand there so that they can see it. When this will get inhibited, right, then it will release less GABA. And this will not be inhibited. Its activity will go up. When its activity will go up,
This will
right, this will be inhibited. But actually, there should be another connection here, ideally speaking. Is that right? So what happens, when there will be more GABA here, this specific neuron will be inhibited. When this neuron will be inhibited, there is less stimulation to another GABA, right? And what happens? That will become
more excited. This one is
less excited because it was stimulatory. So that will be less excited. Less excited means less inhibition to the next, and that will be positive result.
But we don't want positive, right?
Let me tell you, we want positive. Let me tell you. Now, we have seen a direct pathway, is that right? And we have seen indirect pathway. Indirect pathway is defined as a pathway in which subthalamus is involved, right? Now we know dopaminergic action on the direct pathway, no problem. Now dopaminergic action on indirect pathway. The point which you have to understand that glutaminergic activity and dopaminergic activity are antagonist to each other on these neurons. Is that right? What is happening? They are antagonists to each other. Now how exactly it happened? I'm going to draw this complex here. Suppose this is the neuron, right? Here it is releasing glutamate, is that right? And let's suppose on the same neuron, what is being released here? Dopamine, right? So here is dopamine 2 receptors. Dopamine 2 receptors, and here it is glutamate. Now what is happening? This is loading the cations in, and this is the removing the cation. What will be the action? That will be the net of them. Am I clear?
Zero. Why?
Not necessarily zero. Maybe this is released more and this is less.
But why do you need that? I mean, this is
A fine tuning. There's a concept of fine tuning because we don't want it over inhibition in this pathway. Is that right? Or over stimulation in this pathway. So what happens that this is stimulating the direct, what is this? Indirect pathway. This is inhibiting. And both of them are putting a balance there. Now what happens? If there's more action potential coming from here and there's less action potential coming here, net effect will be stimulation. If there's less action potential from here and more action potential from here, net effect will be inhibition. How it happens that now I think this is a very basic concept. In the neuronal cell bodies and dendrite, their potential, membrane potential keep on fluctuating depending upon the balance of stimulatory and inhibitory activity. Is that right? And neuron will fire or not. It depends on what is the net potential in that. For example, threshold potential is, let's suppose, this is having resting membrane potential minus 90 millivolt, right? Threshold potential is, suppose, plus 20. Is that right? Now what happened? In this neuron, resting membrane potential is fluctuating like this. When this is firing, cations are loaded, this is resting membrane potential and this is threshold, minus 70. When cations are coming, this potential is going upward and from this side. But when this is firing, this potential is going downward. So depending upon what is the net effect, frequency of action potentials will be determined.
in that case you have to reach really a certain point to fire up.
Yeah, that's right. Resting membrane potential has to reach to the threshold, only then it will fire. But if resting membrane potential goes above the threshold, then frequency of action potential will be changed. More it is above the threshold, more higher frequency of action potential. Is that right? We have gone away from the topic. Let's go back. Listen again. Rather than making a new pathway, for simplicity purpose, even though different pathways do exist, for simplicity purpose, I will say that neurons in the striatum are under the glutaminergic effect from the cortico-striatal pathway, and they're under dopaminergic effect from nigrostriatal pathway, right? Again. But neurons in the striatum, which are going to globus pallidus internum, they are having D1 receptors. And neurons in the striatum, which are going to the globus pallidus externum, they are having D2 receptors, right? Is that clear? Now, when nigrostriatal fibers fire, right, they have stimulatory action on the direct pathway and enhance the movement, right? And they have inhibitory action on the indirect pathway, and by that they inhibit the movement. Am I clear? They inhibit or enhance? Now this is the question. Again enhance. Let's remove it because this is for that action. Let's start with D2 now. Previous, this is shown, these arrows are actually depicting action of glutamate on this neuron. Now I'm going to draw the arrows according to the action of dopamine, right? Now you see dopaminergic action. Again I will repeat, first direct and then indirect. You people will tell me. When dopamine released on direct pathway, what will happen to this neuron? Under fire, over fire? Over fire. Now you see, it means this neuron overfires on glutaminergic stimulation as well as overfires on dopaminergic stimulation. So both of them, corticostriatal fibers and nigrostriatal fiber, both of them stimulate the direct pathway. When it is stimulated, of course, more GABA here, then these fibers are inhibited and less GABA in the thalamus, and thalamocortical fibers are released from inhibition and more activation. Clear? Here they are antagonists because corticostriatal fibers are stimulating the neuron, GABAergic neuron here, but nigrostriatal fibers are inhibiting it. So they are antagonizing action of each other. Now we see purely the action of nigrostriatal pathway. When nigrostriatal pathway is stimulated, indirect pathway also receives more dopamine because it has D2 receptors. So what happens when D2 receptor is there? Yes, more dopamine here. These neurons get inhibited. When neurons get inhibited, the next neuron are not inhibited at all. So they will overfire. Am I clear? When they will overfire, they will release too much GABA here and inhibit these neurons. And when they will inhibit the glutaminergic neuron from the subthalamus going to the globus pallidus, less glutamate here, less stimulation of the pallidal fibers, and less stimulation means their activity will become less, and less inhibition of thalamic nuclei, right? When there's less inhibition to this, they will overfire. And what will happen? That under the effect of dopamine, direct pathway is also stimulated, and eventually indirect pathway also has stimulatory action in the end on the motor cortex. Yes, please, your question.
When GABA goes down, and you say that as a result, the subsequent neuron increases firing, who is actually changing the action potential to get it to fire?
Come over here. Exactly tell me where you are talking about. Come. Yes. Your question is anywhere. You put your finger and tell me your question. Your question is about the GABA.
Right. When you increase, I don't know where it is now. But basically, when you're increasing GABA, you're decreasing the firing on the subsequent
Neurons. Yes. How it happens? That is what you want to know. I understand. I'm going to explain it.
Okay.
Have a seat. He is dragging me into little micro detail. He's saying when one neuron releases GABA on other, how the other neuron is inhibited. That is your question.
No, I'm sorry.
Oh my God.
That's not my question.
Okay, what is your question then?
The question is when you're turning down GABA.
When you reduce GABA.
You reduce GABA, but the next neuron increases its firing because
Right.
it's being released, it's being allowed to fire.
Right. Now listen.
Who's causing the second neuron to fire?
Very good. His question is this, that if first neuron is releasing less GABA, then I usually make a statement that the next neuron is released from the inhibitory action and it overfires. Question is that why it overfires? First of all, listen, these neurons, dendrite, are very promiscuous. They have connection with multiple different neurons, connected with inhibitory and stimulatory, all those neurons. This is one thing. So usually one mechanism is a multiple mechanism. One mechanism is that this neuron may be under inhibitory neurotransmitters as well as stimulatory. And when inhibitory is dominating, right, it is keeping it away from the threshold. But as soon as this becomes off, then other influences which are stimulatory, they will win over. This is one mechanism. Another mechanism is, let me tell you, some of these neurons which have a tendency to auto-fire, they have sodium leaky channels. Right? They have sodium leaky channels. So all the time some sodium is trickling in. Right? But this okay, I should make it a different color because you should not confuse with GABA. Suppose these are sodium leaky channel, cation leaky channel. All the time some cations are going in. And this is the GABA, which is, for example, this is GABA A receptor, and when GABA acts on this receptor, chloride goes in. Now, cations are coming from there, but chloride is going from there. So what will happen? That effect of cations which are coming in is neutralized by this. Is that right? And this is not allowed to fire. Am I clear? Second mechanism is GABA B receptors. They are associated with serpentine G inhibitory system. When GABA bind with GABA B receptors, they stimulate the G inhibitory neuron protein, and that actually stimulate alpha inhibitory and beta gamma unit. Beta gamma unit basically stimulate potassium channels, and potassium is normally more inside. Listen, when GABA bind with GABA B receptors, these receptors are coupled with G proteins, and G inhibitory beta gamma unit bind with the potassium channels, some special potassium channels, and they open. Because potassium is more in the cell, potassium start going out. So GABA has two mechanisms to keep the neurons inhibited, either by loading the neuron with anions, chloride, or helping the cations to escape. So neuron remain electronegative, more and more electronegative. When GABA is less, either chlorides are not loaded or potassium is not allowed to leak out. And if potassium is not allowed to leak out, it starts accumulating and take the resting through threshold. Am I clear? Okay. Any more question? No question? Okay, let's come back. So what we are talking about, you understand these two things? Right? Now another thing. You may be thinking, what is this? What is this thing? Pars reticularis, substantia nigra. Actually, ideally, pars reticularis should be considered downward displaced globus pallidus internum, because this pars reticularis and globus pallidus internum have the same connections. So these days, pars reticularis of substantia nigra should be functionally considered more like globus pallidus internum than to function like substantia nigra pars compacta. This thing should be clear. It means that this should also have fibers, as globus pallidus internum has fibers going to thalamus. This also should have fibers going to the thalamus. Is that right? It should also receive GABAergic fiber. Is that right? So as GABAergic fibers are going to globus pallidus, what is this? Internum. In the same way, GABAergic fibers also come. Okay, GABAergic fiber also come to, what is this? Globus. What is this? Substantia nigra. Compare this. As these fibers are going there, there are also fibers coming here. And from here, which fibers are going forward? GABAergic. From here also, fibers should be GABAergic. Is that right? But no need to go into this detail. Just remember that pars reticularis is just a functionally displaced, downward, caudally displaced piece of gray matter from the globus pallidus internum. Is that right? Okay. After having all this discussion, now the last word about this thing. As I told you, that direct pathway and indirect pathway are under the influence of, what is this thing? Dopamine. And dopaminergic pathway stimulate the, yes, direct pathway and inhibit the indirect pathway. Then there is also counterbalance also on them. What is that counterbalance? Counterbalance is that within the striatum there are cholinergic neurons, and these cholinergic neurons have influence here as well as here, but they have opposite. Their action is exactly opposite of dopamine. You know, biological system is trying to balance itself. So dopamine had stimulatory action on direct pathway. So acetylcholine will have which action on the direct pathway? Inhibitory. And acetylcholine will have what action on indirect pathway? Stimulatory. Is that right? If you cannot remember that, utmost important is you remember the action of dopamine, right, on direct and indirect pathway. And then remember acetylcholine is opposite to that. Any question here? Done? Now, I'm going to remove this diagram and rapidly make it, and you are going to tell me which neurotransmitter is being released. If you satisfy me, only then I will move ahead in the lecture. Then I will tell you the pathologies of these pathways. First, review the physiology rapidly.